Start recording here. So I do someone have a questions about your online homework here. So if you have any questions, you may ask me. You got 2 homework due this coming Wednesday, which is 5.1 and 5.2. We just did 5.1 on Wednesday, so we'll do 5.2 today. So this question is about 5.1. Here is a question that the students asked me. Let me show it to you. Where is it? Where? Oh, it's not here. So here is the this is 5.1 question number 2. So this is the questions that students ask me about this significantly high and significantly low. I'll just wait because I still have a few more minutes here. Anyone have any questions beside about talking about these significantly high and significantly low questions that comes around? And there are a few questions about that on 5.2 also. So so I will. Anyone have any questions, because it's not 4:30 yet, so we'll wait for a couple more minutes to see if students came in.
Yes. Hi. Could you please re-explain what you sent me on the email?
Yeah.
Thank you.
Anyone have any questions beside the 5.1 question 2 here? Right. So this is, as I mentioned about on Wednesday class, there are 2 ways for us to figure out significantly high and significantly low. One way is using the range of rule of thumb, which a lot of you know this one, where you take the mean plus minus 2 times the standard deviation. Right, this is the one that we did a lot in chapter 3. So if it is low, significantly low, you do the mean minus 2 standard deviation or lower. For high is mean plus 2 standard deviation or higher. So this is the range rule of thumb that you guys are familiar with that we use. Another way for us to figure out significantly high and low is using probability. So this is something new here. So this is something that you will learn this in chapter 5.1, and also we use in 5.2. So when we talk about significantly high in this case, if you want to figure out if like 6 is a significantly high number of success, or a number X is a significantly high number, you need to find the probability of that number or more. And that probability has to be less than or equal to 5%. And if that is happening, then your answer in this case will be yes. Okay, if you have your probability is less than or equal to 5%, then your answer is yes. When the question asking us to find X or more, that means that this is you have to add your probability that goes up, at your probabilities in this case, and you have to add that probability and more. So this is a meaning when I have the word significantly high. Same thing happens when you have significantly low in this case. So when you have a significantly low, we will also use the probability of that number or fewer, and that number has to be less than or equals to 5%. So example, before we jump to the example that we have, so this is very important here. So let's say that based on this we have, let's say that you have a probability distribution. Okay, let's say you got 0, 1, 2, 3, 4, 5, let's say. Okay, and that's this one we only got 5, and let's say this is X in this case is number of let's say girls in a birth. Okay, and the probability of getting 0 girl, let's say this is 0.03, 0.14, 0.25, 0.13, 0.14, is the, let me say 2, 3. I'm going to change a little bit, and then 1, 4. Let me see the last one. As you know that the total has to be 1. So let's figure out what the last one is. So 0.03 plus 0.14 plus, wrong one. 0.03 plus 0.14 plus 0.25 plus 0.23 plus 0.14 minus 1. So this is 0.21. So this is given to you. Maybe I just give another one, so it makes a little bit more better. This is 0.20 and 0.0. So this is given to you, and the sum in this case is 1. Okay. So the question is asking us is let's say 5 a significantly high. In this case, they're asking is 5 significantly high using the probability. I'm not calling you to use the range of rule of thumb. I'm using the probability, means I'm asking you to use this significantly high, significantly low way. So how do we figure out this is 5 is significantly high? Is you have to find what is the, so for significantly high, which is the one I highlight in orange, you have to find what is the probability of 5 or more. So you need to figure out what is this probability is. So how do you figure out the probability for 5 or more? Is you take this and you have to add. So you have to add the 5 and the 6. Okay. So that is the meaning of this. X or more means you have to add. So in this case, it will be 0.20 and 0.01. So this is 0.21. And then you look at it, since this 0.21 is more than 5%. Okay, so your answer in this case is no. 5 is not significantly high in this case. Okay. So a lot of students that make a mistake here is they don't take the addition, they use exactly 5. Okay, which is 0.02 in this case. This is wrong. Okay, so so when I ask you for significantly high, you don't just use exactly. You have to add that number, the probability of that number, and higher. So you have to add 5 and 6 in this case. And that probability has to be less than 5%, then your answer will be yes. Since like this case is more than 5%, so it's no in this case. Same thing happens when I ask for significantly low. So like same thing question here. If I ask is 3 significantly low in this case. So when I ask for significantly low, which is the yellow highlights, so you need to find what is the probability of this number 3 or fewer. So that means that you have to add your probability from 3 or less or fewer. That means this. So you have to add this for probability. So that will be 0.03. You have to add all this 0.04. So if you add all this probability, 0.25 and 0.23, this came out to be 0.65. And this probability is also more than 0.05, sorry, it's more than 0.05. So in this case, that is 3 is significantly low, your answer in this case will be no, because this is not significantly low, is 0.65 is more than 5%. And again, we don't use the exact 3 in this case. So a lot of students just look at exactly 3. and figure this one out. So this is the main mistake that a lot of students do here. So, so this ties up with your homework, this question. This question is asking is out of 100 births, the exactly 57, probability of exactly 57 goals is 0.0301, and probability of 57 or more goals. So when it has 57 or more goals means like what we did here is you add the probability out, and that probability is 0.097. So the question is asking is the 57 goals in this case significantly high? So how do we answer this question is you look at your probability. So again, we don't use the exactly one. So this exactly 57 goals is no good. So we don't use that because for significantly high, we have to use that number or more. So we are using this number. Okay, and this number is more than 5% because 0.097 is greater than 0.05. So in this case, your answer will be we are using 57. We are using 57 or more goals. The reason why is we are using a significantly high, and that percentages is not a significantly high number. Is because this number is greater than. So this is how you answer this kind of questions when you talk about using probability in this case. So we use this number. It's always more or less, depends on significantly high or significantly low. And then you look at these percentages. Since these percentages is more than 5%, then it's not significantly high. So this is how we do this. So you don't use the word exactly in this case. Okay. There are some questions also asked the same type of questions where they give you the whole table here, and then they will ask you the same thing for this. Example will be like this question number 8. They give you this, again, is a number of girls that we have. This is the probability distribution. So the first question is asking us, what is the probability of getting exactly one girl in this 8th birth? So can someone tell me, looking at this probability distribution, what is that probability is? Exactly one. Anyone?
0.003.
0.003?
Yeah.
That would be wrong. I'm asking for exactly one girl.
0.036.
0.036,
I'm sorry.
right? That is for 0 girls. So be careful. So this is exactly one. And then the next one is asking for one or fewer. So what is the meaning when I say one or fewer girls?
That's going to be 0.003 plus 0.036.
Yep. So fewer means you have to add, right? So you have to add the 0 and 1. So you will take 0.003, the 0, and the 0.036. So that will came up to be 0.039. Okay, so you add the first two of them. So the question now is asking is, which probability are we using here to figure out one is a significantly low? Is that from part A or is it from part B? So which one are we using when I figure out one is a significantly low? Part A or part B?
Part B.
Why we use part B in this case?
Because that's the one that tells you that has fewer number of girls.
So what we're doing here is, the reason why we don't use part A is because the word is what?
Exactly.
Exactly. So as I mentioned here, you don't use the word exactly to determine the probability. If it's a significantly low, we always do the fewer one. So that's the reason why we do part B. And this case, we are using 1 because the question is asking for 1. So we're looking at part B. So in this case, part B is more relevant here than part A. So your answer is either A or C because part B is the one that we are talking about. The reason why we so it's either these two. So since the probability of getting more than, now we don't use more than. If you use 1 or fewer, we don't do more, we do less. So in this case, since getting 0 go is let me see, since getting 0 goes is an even. No, it's a complement result. Let me see. So it's either a since getting 0 goes. No, this is not the right one. This is the one that is this is a very play on words because of the word complement. Complement means opposite. So since the probability of getting more than 1 go is the complement of the result, complement means the opposite. So like if I say 30%, the complement will be 70%. So complement means like the opposite of 30%, which is 70%. So this is the answer in this case. In the test, usually I would just say which part you pick, but I wouldn't tell you why. So in this case, part B is the one that we pick. And oh, let me see. Then it's C. Yeah, I think it's for me is in the test, I won't come up with these kind of questions. I will ask you part A or part B. This one is really tricky here. So so it's gonna be C in this case. So usually I don't know why they put it this way, but so it will be, yeah, don't worry about this part. The only part I want to point out to you here is we don't use part A here. That is my main goal, is because we don't use the word exactly. We always use one or fewer for those with significantly low. Okay. And then now we figure out if this is more than or less than 5%. So by looking at your probability, this probability, again, we are looking for part B, not part A. This probability, is this less than or more than 0.05? 0.039.
Less than.
It's less than. So since it is less than, so your answer in this case will be yes. The reason why is because it is less than that. Okay. So your answer will be yes. So usually in the test, I will ask you which part do you pick, part A or part B? Just that I usually explain what happens. Usually very straightforward type. And then the next one is asking is this one is a significantly low? And the answer in this case is yes, is because this number is less than 5%, 0.05. So what I want to point out to you guys here is that again, this is very important. When we do significantly high, we use 5 or more. Okay, 5 or more. So if I ask if X, I change this to become an X because it can be 4, it can be 6, it can be any numbers. Then you have to do X or more. And how do we find this probability? Is you have to add them, like what I just did just now. I add those, and then figure out if that number is more than or less than 5%. If it's more than 5%, your answer is no. If it's less than or equal to 5%, then your answer is yes. Okay. And again, for the significantly low one, I put an X here because it can be 2, it can be 1, it can be 3. Then you have to use X is fewer, means you have to add the fewer one. And this probability also has to be less than 0.05. If that number is less than or equal to 0.05, then your answer is yes. Otherwise, your answer will be no. Sully, you got what I'm trying to say here?
Yep, thank you.
Yep, and you will get more examples in 5.2 because 5.1 and 5.2 is using the same thing. Okay, so we will be using this again. So I will save this so you guys can probability for significantly high. Okay, so this is what we will be talking about. Yep, I will bring this one up later on. So anyone have any questions that you have on your homework? Make sure you use this to find your mean and standard deviation. Okay. So what we do in 5.1 is called probability distribution. So in 5.2, which is today's class, we will talk about binomial probability distribution. So this is what we call as a discrete case. And don't forget, the whole chapter 5 is about discrete. And how do we know it's discrete? The keywords for it is number of, right? Remember number of. So every time when you see number of, that is the discrete case here. So for this, we also will talk about number of. So that's why we will tie this together with chapter 5. But it has to be binomial in this case. So what is a binomial probability distribution? In order for us to have a binomial probability distribution, it has to go through these 4 requirements. And if you did not have these 4 requirements or miss one of these requirements, it is not a binomial case. The first requirement means it has to have a fixed number of trials. What is trials? Trial is observation. So in other words, the first requirement says that you need to know n. Okay. And what is n here? N in this case is how many trials do we have? So it's very easy to figure out. Is by if you have a table like this, n in this case will be 5. Okay, n is always the last number on the x. This is your n. So if I give you like a table here, your n in this case is 5. So we got 5 people in this case. So usually the question will provide us n in this case. Like the one that we did here, your n here is 8 because they got 8 births. So that means you got 8 trials. You got 8 kids, and it can be boy or girl out of these 8 kids. So that is what we call as n in this case. Okay. So that is the first requirement, means that you need to know n, and usually it's given in the question. Okay. The next requirement is it has to be independent. So what is mean by independent? Independent means that the outcomes of one trial does not affect the outcomes, the probability of other outcomes. For example, it's like having kids. So let's say you got the first kid is a girl, and the second child in this case, the sex, male or female, does not depends on your first kid. The second kid that you have is completely independent, means it can be male or female. And then your third, if you have a third kid, your third kid doesn't depend on your first 2 kids. That means you still have male and female. That means the chances are the same, 50-50. So it doesn't mean that you have 4 kids, 4 girls, and then the 5th one, the chance of you getting boy is really high, because since you got kids, 4 girls in a row, then the 5th one is definitely a boy. You know, a lot of people have that kind of thought, like, you know, you got girl, 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 girl. Oh, this 5th one is gonna be for sure 100% boy. My question, my solution to you is no. The 5th one, the chance of you getting a boy is still 50-50, because it doesn't depend on the previous outcomes. So that is the meaning of independent, means that what your outcome here coming out is not going to affect the other outcome. Okay. Because of it binomial, so the third requirement here, it has to be 2 categories. We call it that success and failure. And the last one that we have is the probability for the success is always the same in all trials. So what do you mean by the 4th one is, like since we got like 5 kids, right? So the first kid that you have, the probability of you getting male is 50, probability of getting a female is 50%, 50-50. And then when you have a second kid, the probability of getting male is also 50, female is 50. The third one, 50-50, 4th, 50-50. So no matter how many kids you're gonna have, the probability is the same for the rest of it. So that means they're all 50-50 for every trial. So people who have gambling behavior or gambling habits or gambling problems, is they have these mental issues that they don't think the probability of success is the same for all trials. It's like what I just mentioned here is, you go gamble, you lose. The second time, you lose. The third time, you lose. The 4th time, you lose. You play 4 times in a row, all 4 times you lose. You got nothing. You didn't win anything. So a lot of people have this gambling mental, is they say, oh, you know what? The 5th one is going to be win, because eventually I have to win, right? So what happened is that the 5th one, I'm going to bet a lot. Instead of $5, I'm going to put $500, because, you know, this is not definitely I will win. I would want to tell you that the 5th time that you bet, the chances of you winning is the same as the first time you bet, which is, I do not know, maybe 30% or 20%. So so that's the reason why that a lot of people having gambling habits or gambling behavior or gambling problem is because of this probability. The thing is you lose, then this one is going to win because the chance of it is higher. I can tell you the chances is the same as the first time you gamble or first time you place a bet. Okay, so so those people who have issues with gambling, please make sure you get some help because instead of $5, you put $500. You might lose this one, so you don't know. The chance is still the same as the first time you play. Okay, so these are the 4 probabilities. So 4 requirements for the binomial problem distribution. And if one of these does not work, it's no longer called binomial probability distribution. For example, if you remember the number of TVs that we have here, okay, the one that we say how many TVs you have in the household, this is not a binomial case. And the reason why this is not a binomial case is because it fails number 3. Okay, so this is not, so this example that we have here is not binomial distribution because it fails the 3rd requirement. What is the 3rd requirement? The 3rd requirement says it has to be 2 outcomes. So so this is fail on the this requirement, which is 2 categories have success or failure, is because this one is how many TVs, right? So it can be 0, it can be 1, it can be 2, it can be 3, 4, 5. So that means you got 6 different outcomes. So it's not a binomial case in this case. It's because it has to be 2. So that's the reason why this fellow is no longer, it cannot be used in this section 5.2. Okay, so make sure you guys know not everything is binomial. Okay, and if it's not binomial, you cannot use this section 5.2. Okay, there is one special one, and the special one is this number 2. Okay, the independent case. So this is what we call as the 5% cumbersome calculation. So when you have a sampling without replacement, without replacement is usually a dependent case. I will tell you what is the meaning of that. But we can treat this as an independent case as long as the sample size is no more 5% of the population. Okay, so I'm going to tell you what is the meaning of this. Okay, what's the meaning when the keyword here is definitely without replacement. So when you guys read this keyword in your homework or in your test, is talking about this special requirement. Okay, so what I'm going to point out here is that what's the meaning of without replacement? So let's say that we have a group of students. Let's say we only got 14 students in this case. Okay. What is the meaning when I say without replacement is I take one, let's say I want to pick 2 students out from this group, okay? And if I pick 1 student out, without replacement means that you don't replace it back to the group. Means that once I pick 1 student out, this student will be taken out from this group, okay? So what happened is that this 14 student is no longer 14, it's 13 because I take 1 out, right? So what happened is that your sample size is getting smaller. And when your size is getting smaller, the chances of me picking you, the second person, is really high because your group is getting smaller by 1. So instead of 14 students, now you only got 13. So the chances is pretty high to pick another student out. So this is what we call as without replacement. And this is actually a dependent case. It means that it depends on which students I pick it up. So example is if I pick the first student is Casey, Casey's will not be picked again because she will be without replacement. She will only pick 1 time and she'll be not putting back in the group. So what happened is that now the group is it's not 14, it's 13 students. So the chances of me picking the next students is really high, higher than the first time. So, so this is a dependent case, but as you know that in order for us to have a binomial, the second requirement for binomial says it has to be independent. So sometimes when we pick people without replacement, it is a dependent case. So we can treat this as an independent case as long as your sample size, the one in highlight purple, purple or orange, is no more than 5% of the population. So another words in this case is, I just put it down in the formula way, n over by capital N is less than or equals to 0.05. So what is n in this case? N in this case is how many people we pick without replacement. And capital N is out of how many people. So this is total people in the group. In the and we want to figure out if that number is less than or equal, again, 5%. We always use 5% as our kind of a cutoff point here. So how do we, so in order for you to do this one, since I picked, I picked 2 students. So n in this case will be 2. So I picked 2 students out of 14 students. So I have 14 students in this class. So what we do here is we divide this. So 2 out of 14. What is this number is? So 2 divided by 14 is 0.14 something, 0.14. So this number is more than 5%. So if this number is more than 5%, then it is a dependent case. Okay. And in order for us to have an independent case, this percentage or this number has to be less than 0.05. And since this is more than 5% is a dependent case, then this, when I pick these 2 students out of these 14 groups, is not a binomial distribution. Okay, so it's not a binomial distribution because it fails the second requirement. It fails the second requirement. So again, the keywords that you guys need to look at here is the word without replacement. And what we do here is we take the n divided by capital N, and if that is less than 5%, good. That is good news. Otherwise, the dependent case will be when it's more than 5%. So that is the meaning of the Cumberson rule. Again, keyword without replacement. If the question does not have the word without replacement, then usually that this will go true. Okay, so so that means if the question does not have without replacement, means it is independent. Okay, so mostly of the questions that you read through it, they don't have word without replacement, so we assume that it is independent. For example, will be like the girls, okay, like the girls that we did, 1 girls, 2 girls, 3 girls. We do not need to assume that because we know that it is independent already because the second kid doesn't depend on the first kid's outcome. If we talk about drawing cards from your deck of cards, that is depends on how I do it. If I draw, like, let's say, you know, a deck of cards has 52 deck cards, right? So if I have 52 cards in a deck of cards, if I draw only 2 cards out without replacement, so is that independent or is that dependent? So what we do here is you take the n divided by capital N. So you take 2 divided by 52. And what is this number is? So 2 divided by 52 is 0.038. This is the number that we get. So is this number less than or more than 5%?
Less than.
So if this number is less than 5, less than or equal to 5%, then this is independent. Okay, Independent means good news because it fulfilled number 2. Okay, so that means that it fulfilled the second requirement. Okay, but for this case, it does not fulfill the second requirement. So you have to do a little bit of calculations for this case, and the keyword here is without replacement. Okay, again, read the question really carefully when you guys do the homework on my test. Okay. Then we got some notation here. So the first notation we have is the S and the F. So when you use capital S and capital F, it stands for success, failure. Okay. So so usually we use S and F, capital. We also use letter P. P in this case is the probability of success. We call it as P capital S. We don't use that, we use P. And we also know Q. Q is a probability of failure. And how do you find Q? Is 1 minus P. So which is what we call as a complement. So usually in the test or in the questions, they give you the probability of success. They will say that let's say they will say 43% of them is blue color. So they say, oh, this chance of you getting blue color is 43%. Can you tell me what is this is considered P? So this is your P here. Okay, so can someone tell me what would be your Q in this case if I say 43% is blue color? You do the
57%.
Yep, that will be 57%. So usually, how do we find 57%? Is you take 100%, subtract 43%, or take away 43%. Or if you add P and Q, you get 100. So if you add these two numbers up, you get 100%. So usually this is given in the question. But unfortunately, this is not given. So they will give you one, but not give you the other one. So you have to find the other one, and it's very easy to find the other one. Is you just subtract from 100, and then you will get. And usually one's called success, one is called failure. Okay, so Q in this case will be called not probability of not getting blue. Okay, this is getting blue color, so this will be not getting blue color. This is the meaning of the failure here. So you don't get the blue color in this case. And usually it's not given in the question. So make sure you guys understand how you figure out this Q, and it's not that difficult. Okay. We also mentioned N. N in this case is number of trials. And if you have a table, make sure you read the last X equals to. So the last one on the X is your N. And usually they will tell you how many people we pick. Or instead of people, sometimes it can be items like cars and stuff like that. So how many people do we pick? So that will be your N in this case. Okay, how many people we pick? Yep. X in this case is the number of success in each child. This is what we call as your random variable. So if you remember that when you draw on the table here, this is X in this case. X will be 0, 1, 2, 3, 4. This is called a random variable, and N in this case is 5, right? The last number here. So this is X here is called a number of success. Usually this X has to be whole numbers, 0, 1, 2, 3, 4, 5. In the questions, they will ask you, if you pick 6 people, what is exactly 2, exactly 3, exactly? So when you use the word exactly, that is the X comes up. Okay, and then when you have the P in front of the X, is talking about what is the probability of you getting that X success. So example is, what is the probability getting exactly 1? Your answer is 0.15, the one that we just did, 5.1. So they will use the word exactly in this case. So you do not need to memorize this formula. Please don't use it. And again, class, if you do help me to solve this in this section, you will see this formula pop out and you will be crying using this formula because it's very difficult. So I will not use this formula. We will be replacing it with StatCrunch. So in StatCrunch, you use stats, calculators, binomials. You need to enter N in this case, and you need to enter P in this case. Okay, so N in this case is for sample size, or number of trials. P in this case is probability of success. And if the question is asking you for, if the question is used exactly, you have to use the equal to symbol. If the question say more than, you have to use greater than symbol. Less than, you use the less than symbol. Make sure you know which symbol is which. When they use the at least, or sometimes they use the word significantly low, remember the one that we talked early on, then your symbol is going to be less than or equal to. And when you use at most, or the word significantly high, you use greater than or equal to. So make sure you guys know what you pick, because in your question, they will give you one of these numbers. And next to the next symbol is your X. X in this case is a number of success. So remember last time we asked for 1 is a significantly low, so that 1 is your X in this case. Or sometimes I ask exactly 3. So 3 in this case will be your X in this case. And make sure this X must be whole numbers. So this is very, very important that I highlight here because this is something that you guys need to know. Okay, so I'm going to put down some little word here for you, so you guys got the meaning of it. So now talking about probability. Okay. So what happens when I use the word exactly? This one you guys know, right? Exactly means that exactly 3 means equals to 3. That means you look at exactly equals to 3 here. What happens when I say at least 3? This is very important, class, so please pay attention here. So at least 3. So let's say if you use back this probability distribution, exactly 3 is 3 equals to 3. So your answer in this case is 0.26. Okay. Now, what is the meaning when I say at least 3? At least 3 in this case means 3 plus. And what is 3 plus in this case? Means that probability of getting 3 at exactly 3 plus probability of exactly 4 plus probability of exactly 5. So that's the reason why that I use 3 plus. In your StatCrunch, they use greater than or equals to 3. That means 3 and higher. And if you look at this table, you have to add 0.26, 0.16, and 0.12. And I think you guys know how to add using your calculator. So whatever you add using, so you have to add these 3. So the keyword here is at least. A lot of students think the word least is less, so they go to the smaller, smaller than 3, but actually it's greater than 3. Okay, greater than or equals to, it's include 3. Okay, and then these are the really difficult words, and because reason why I'm showing you all this is because you will see this in my test, and I like to use the word at least, and the next one come out exactly, And what happens if I ask you to find the probability of at most 2? So the word at most 2 means that it is less than or equals to 2. That means 2 or less. So for this case, you have to add 2, probability of 2, probability of 1, and 0. That means you have to add anything that is 2 or lower. So if you look at this table, you have to add 0.29, 0.15, and 0.02. So that is the meaning of the word at least and at most. So that's why when you look at this this formula here, when you have the word at least, it is you use at least is yes. Let me see. Sorry about that. Yep. This is wrong. Sorry. This is wrong. I am so sorry. This is completely typed wrong here. I was like, this is. Can you, if you guys have this hand up, can you please change this? I was like, this is not at least. This is at most. These two got switched around. Sorry about that. So this is at most, and this is at least. I was like, something. I was like, so can you please, I need to change this. Oh my God. So can you change at most is less than equals to, at least is greater than equals to. Yep, this is correct. So please switch these two around. Those who have my notes, it's like reading it's like, what's going on? This is, so that is the meaning of the word. Yeah, this is, I'm showing you this is correct. This is a typo here. Yeah, I need to change it when I finish with this class. So at most is less than, at least is greater than. Please change this class with your notes here. Ooh. Then the word more than and less than is a little bit special than this. Okay, so I'm going to tell you the difference here. So at least 3 means 3 or more. So what happens if I use the word more than 3? Does that include 3 or not? When you use the word more than 3, if you look at no, yes. So that means you only do 4 and 5. Okay. So that is the difference between the word at least 3 and more than 3. At least 3, you include 3 and higher. More than 3 means 4 and 5. You don't do higher. So make sure you guys know that this is very important. That's why I need to teach you guys all these little English words that are very, tricky. And same thing with less than. So probability of less than. Okay. So when I say less than 2, do we include 2? If I say probably less than 2, no, you just include 0 and 1. So this is 0 and 1. You have to add them up. So make sure you guys know the difference between this at the less than and at most, where this is include 2, this is not include 2, so you don't include 2 here. And the other one, you don't include 3. So that's the reason why when you look at the symbol, one of it has an equal sign, because when you say an equal sign, means it includes that number. And when you don't have the equal sign, means it does not include that number. Okay, so again, be careful with this. Mean and standard deviation. So there is a way for us to find the mean and standard deviation. You do it early on in this section 5.1. In order for you to find the mean and standard deviation, you have to enter your random variable x in var1, and then you have to enter your probability in var2 or import it from your data. And then you go to stat, calculator, custom, you do all this work. You can do it, it's not a problem, but there is a shortcut for it. As long as it is a binomial, the mean in this case is n times p. Again, the binomial, if its mean is n times p. For the standard deviation, is the square root of n times p times q. So there is a shortcut for us to find the mean and the standard deviation. Remember last time you put everything in your StatCrunch and do the stat calculus custom. So as long as it's a binomial case, you can do it by n times p and the square of npq. I will show it to you an example. The shortcut, which is this formula, and the longer way, which is not too long. You just need to enter a lot of numbers in your StatCrunch. Okay. No matter which way you do, you still get your same answer. The only thing here is this 2 is a formula you need to memorize. So yes, these are the formulas you need to memorize. When I say memorize, means put it in your your 1 page of paper here. Quite a lot there now, right? If you start writing on your little cheat sheet for using for your test. So make sure you start working on it now, because your test is coming up in a couple 2 weeks, right? I think it's next 2 weeks. So make sure you start working on your little piece of paper. Once we know the mean and the standard deviation, then again, basic stuff, we can use the range of rule of thumb to figure out low and high, which is a mean minus and mean plus 2 solution. And we can use the probability, which is the same thing we talked about in the beginning of the class. If you have a high, you use more. You have to add up, and then that percent will be less than 5%. If you have low, fewer, it has to be also less than 5%. This is exactly the same thing we just talked about on the beginning of the class. Okay, for 5.1, it's the same. So again, there are 2 ways for us to figure out, are they significantly low or significantly high. One is use the RROT, and the other one is using probabilities. Okay, so there are 2 ways to do it. So we'll look at some examples so you can figure out what's going on here. Question 1 is asking us if this procedure result in a binomial distribution, and if it does not, can you tell me what requirements it does not satisfy? So this kind of questions, you will get it in my multiple choice question. In my test, as you know that the first 10 questions in my test is multiple choice question. And then the next 4 or 5 questions is open-ended. Open-ended looks something like this, where you have to type it in. So this is the one that I like to ask multiple choice question. So as you know that for binomial distribution, you have to fulfill 4 requirements. So the requirements is way up here. So 1, 2, 3, 4. Okay. So let's read the first the question here. So the current Senate consists of 83 males and 17 females. Does anyone know how many senators we have in the States? Anyone? How many?
100.
Yeah, we have 100 senators. 2 for each state. So we got 50 states, so we got 100 senators. That's why 83 of them is male out of the 100. 17 is female. So when you add this one, you get 100 senators here. And then we pick 40 different senators are picked here. And we're gonna pick this without replacement. So this is the keyword. Remember the keyword I call you guys to watch carefully. So this is a big keyword, without replacement. And then we ask what's the gender that we pick? Is that male or female? So is this a binomial distribution? So in order for us to go through that, it has to go through the 4 requirements. So the first requirement is you need to know n. Do we know n in this case?
Could it be 100?
No, that is not your n. How many people we pick? We didn't pick 100 people.
Oh, you just add
40.
40. So that is your n. So don't forget, n in this case is how many people we pick. Okay. That will be your n. So in this case, since we know n, this is good. Okay. If you doesn't know n, no good. As I tell you, make sure you read the question carefully. So this is 40. So that's why n is known. Okay, we know the first is good. Next we have is a second requirement. So second requirement is talking about independent. Okay, that is the second requirement. However, we have that cumbersome rule because of the word without replacement. Okay, so that's the reason why we go back to this little dot here, the blue dot, because of the without replacement here. So that's the reason why we need to check this independent rules. So what we need to do is we need to figure out if your n over capital N is less than 0.05. Since we know n in this case is 40, can someone tell me what is your capital N in this case?
That's 100. 100.
This is 100, means that that is the total people we have. Okay, so what we do here is we need to do n over by capital N. So this 40 over 100. So this is 0.4. Again, calculator. This is less than or more than 0.05.
It's more than 0.0.
It's more than 0.05, right? So is this considered independent or dependent? Since it is more than 0.05, is this considered independent or dependent?
Dependent.
This is dependent. Again, in order for us to be independent, it has to be 5% or less. Okay, this is more than 5%. So is that good or bad? As you know, that requirement, second requirement says it has to be what?
It's bad.
So this is bad. So this is no. So actually, the question is, do you need to check the third and the fourth requirement? Do you need to check these two? The answer is no. So once we know one of them is bad or does not fulfill, so the question is asking, is this a binomial distribution? Yes or no?
No.
No.
So this is not a binomial distribution. Why this is not a binomial distribution? Because it fails which condition? Which condition it fails? The second condition, right? which in this case is independent. Okay. So so this is what I will ask in the test. I will say, oh, this is a question, and I'll ask, this is multiple choice. I will say A. Yes, it is a binomial because it passes all the conditions, all the requirements. B, no, because we don't know n. Okay. C is this fellow. No, because it fails, it's not independent. Okay, so I say it's not independent. Okay, this is C. And then I will also say D. So this is like a multiple choice in your test. D, no, because it has more than 2 outcomes. Because the third condition is you have to be exactly 2 outcomes. So this one has more than 2 outcomes. And E, no, because the probability of success is not the same for each trial. So this is exactly like this AB, this one, 1, 2, 3, 4. So what is your answer in this case if I came up this in your test? Your answer will be A, B, C, or D. Your answer will be
C.
C. Because this does not pass the independent test, independent condition. So this is what I did in my multiple choice. So make sure you guys read the question carefully, and then make sure again you do not show any work, but because it's a multiple choice, you just tell me it's A, B, C, D. Okay, and your answer here will be C. You guys all right here? So you kind of know what my test looks like now. So question 2, this is the one that you will get as an open-ended, means you have to do a lot of work. So what you need to do here is read the question. Yep. And on question A, can someone tell me what is your N, what is your P, and what is your X? Because in your StatCrunch, you need to know your N, which is a sample size, P, probability of success, X, number of success. And then you need to know equal or so on. We'll talk about that. So read question 2A and tell me what is your N, P, and X. What is your N? What is your P? What is your X?
8.
N is
8.
8. Yep, which is given us 8 adults. P is the probability of success. 54%. But you don't use 54%, you change it into decimals, 0.554. And what is X in this case? What do we need to find?
6.
6. Yep, 6 will be the one. And there is a keyword next to the 6 is the word what? Exactly, right? See the word exactly? So what symbol should we use for exactly? Equal to, greater than, less than, greater than equal to, less than equal to. Which one we pick?
Equal.
Equal. So you have to pick equal. Okay. So now what you do here is you go to your StatCrunch, go to Stat, Calculator, Binomial. So I'm going to go to the StatCrunch here. X this follow up. So go to the StatCrunch. Go to Open StatCrunch, StatCrunch website, and open StatCrunch. So this is you don't need to import everything. So what you do here is you go to where we go to, let me see. You go to where? Stat, calculators, binomial. So if you look at here, you go to stat, calculators, binomial. Last time in 5.1, we go to custom. You know, all the way down, you see custom, that is 5.1. Now in 5.2, we do binomial, and they will this pop out. So this is where you put the numbers I told you. N in this case is 8, right? Right, N is 8 in your, so N is 8. P is 0.54, so you put 0.54 here. Then you use this exactly is equal, so you use equal sign here. So you click on here, you got 5 choices. Exactly we use equal, and how many X in this case? This is the one that you put the X number 6, right? I think we put 6, right? 6. Okay, and you hit compute. This is your answer. Now, how do you write your answer? The last row. Copy down the whole last row. That is your answer. And I do not want you to give me so many decimals. Give me like 2 or 3 decimals. So your answer in this case, make sure you copy this whole thing down. Just give me that. I might just minimize that for now. So this is the one I need to do. So we are using this a lot in this class. So how do you write this in your homework, in your task? Is copy down the whole thing. Capital P, parentheses, X equals to 6, close the parentheses, equals to 0.17 or 147, something like that. So this is how you write this in my test to get full points, this whole thing. If you just give me 0.147 in your test without writing the one at the back, you won't get the full points. Okay, so you have to tell me your N, your P, your X, and then this exactly optional. If you want to do this, it's up to you. I'm doing this is because for you guys to know what's going on. Okay, and this is your answer here. Okay, but I want this everything that I've written down here. So make sure in the test, don't give me 0.147. You will get not the full point. Okay, part B. I want you to read part B again and do the same thing. What is your N? What is your P? What is your X? Read part B again. So make sure you know how you calculator, binomial. Stats count. Anyone know what is N here for part B?
N is 20.
P, probability of success.
Is that always going to be the 0.54?
For this question, yes. So
Okay.
the whole question 2, the probability of success is 0.54 for this question.
Okay.
So for A, B, C, D, E, we use it. Same thing in a test. So if I give you this is used for the whole A, B, C, D. And what is X in this case?
15.
15. And what is the word that we have here?
Exactly.
Exactly. Means equal to, right?
Yeah.
So can someone tell me what you're going to put in your stat crunch for all these numbers? N is
20.
20. P is still 0.54. And which one should we pick for this case?
Is equal to
Equal to, and this number is what?
15.
15. And you hit compute. So again, don't look at the graph. The graph is, do not look at the graph. Okay, you guys still taking this class. Again, I'm not very picky with lower X or capital X. So it's capital X actually. So I'm going to use capital X. If you put lower X, I'm fine with it. 15. This is equals to 0.031. Again, 2, 3 decimal place. I'm not picky. Okay, as long as you give me 2 or 3, I'm fine. You guys have any questions for me? Okay, read C again. So go ahead, read part C. A lot of reading here now. Yep, chapter 5 onwards is a lot of reading. And in the test, I recommend you to underline or highlight those important keywords, like exactly is what you see over there for BAB. Anyone know as N for question C?
N is 10.
10. P is
P is 54.
0.54. X,
X is 8.
8. Yep. But the keyword now is not exactly. The keyword is what?
At least.
At least. See, the keyword is at least. So if you look at this here, which one is at least? Is that equal to, greater than, less than, equal to, greater? Which one is at least?
Greater than.
Greater than this one? At least is what? Greater than or equal to, right? So this is at least.
Okay.
You guys with me? So when you have at least, you will use greater than or equal to. Okay. So again, how do we enter this into your StatCrunch? Is again we change this. So N in this case is 10. P is still 0.54. This, which one are we picking? 1, 2, 3, 4, 5. Which symbol will we pick? And if you pick the wrong symbol, you get all wrong. Which symbol we pick? 1, 2, 3, 4, 5.
2.
Number 2. This is the word at least. And what did we put in here?
8.
8. So, and you just copy down. So P X greater than or equals to, I don't have a say. 8 is equals to 0.089. You guys okay? Anyone have any questions for me? And please don't help me to solve this. Otherwise, it's not as easy as this. Okay. Read question D. Again, what is your NPX? So when you do a binomial case, this is what you need to do, NPX.
N is 12.
P
is 0.54.
And X?
X is 3.
3, yep. And the keyword that we're looking for?
Fewer than. Less than.
Fewer than. So fewer than is the same thing as what?
Less than.
Less than. So which symbol are we used for fewer, less than?
This one.
This one, right?
Yep.
So you have to use this symbol for less than. So go ahead and type this into your StatCrunch here. So N in this case is 12. P is still 0.54. Which one of this symbol is less than 1? If you look at the top, 1, 2, 3, 4, 5. The last one is equal to 5.
The third one.
The third one. And X is 3 here. You guys doing okay?
Yep.
And compute. So this is Px less than 3 is equals to 0.010. If I round to 3, the 5 is big enough to round up. So you guys doing okay? Is this tough?
Not really.
Not real. Again, read the question, right?
It's not, well, it's easy because you're explaining it this way,
Yeah.
but
And again, don't you will see something very similar like this in your in your homework and tests. So don't help me to solve this. You will be really confused. All right, the last one is E. Read question E and tell me what is your NPX.
N is 6. then P is 0.54,
and X is
5.
5, right? And
Yeah.
what is the keyword we have here?
Significantly high.
Significantly high. So if you look at the here, which one is significantly high? Equal, greater, less or equal, greater, equal. Which one is significantly high? Which symbol?
Greater than equal or
Greater than or
equal.
equal to this fellow, right? So we're gonna
Yeah.
use him. Okay. So what we do here is we're gonna use the same thing. So we just plug in here, and it's 6.54. Greater equals to is the second one, and 5, right? We're gonna do 5 here because that is your X is 5. So this is, again, we write this 0.152. Now this question E is a little bit different from A, B, C, D. Last time you just, okay, I'm done, right? Move on to the next question, right? This one is a little bit special. It's because we find the probability, which is the 0.152. So my question is 5 significantly high? Remember, in order for you to answer yes, the percentage has to be what? Less than or equals to what?
0.05.
So my question is this number less than or more than 0.05?
Is greater than.
So this is greater than 0.05. So your answer is 5 significantly high? Yes or no?
No.
No, it is not significantly high. Because 0.152 is greater than 0.05. Yep, this is usually how we reply it. You just figure out if this number is less than or more than 5%. If it's more than 5%, the answer is no. If it's less than 5%, the answer is yes.
So, Prof, it's quite ironic, though, that even though this number is higher than 0.05, it's still not significant.
Yeah, it's not significant high. Yep.
Even though
It's not an outlier.
Even though it's higher than 0.05.
Yeah, don't forget, so it's considered outliers, it have to be less than 5.
Yeah, I get what you mean. Yeah, I get what you mean. It's ironic.
Yep, ironic, yes. If you look carefully on the graph, 5 is here, but 6, if you look at 6 is very small, right? Look at 6.
Yeah.
So if you get 6 is a significantly high in this case. Because the probability is smaller than 5%. So the graph, you can kind of looking at it. So 5 means you had to add the red one. See the 2 red lines?
Yeah.
So they add the 2 red ones, it came up with 0.152. And since that is higher than that, so we say it will be significantly. It's not a significantly high in this case. I know it's very tricky. It's a lot of students get a bit confused on this one. Questions? Right. Read question 3. Okay. Tell me your N and your P and your X. Read question 3.
N is 10.
So we got a group of 10. So N is 10.
Then P is 0.75.
P is 0.75, which is given here, the probability of success. Do the question give us X? No. Okay, so in this case, the question didn't, only part C, the question gives us X. Okay, so but this question wants us to find something else. It's not finding the probability. If you look at here, they ask you to find the probability. This question, if you read part A, they want you to find what? The mean and the standard deviation. So there's a lot of work if you type this into your your work here. So one way for you to find out is type what is n is. N in this case is 10, right? And then p in this case is 0.75. And then you do exactly, you're gonna do a lot of work here. I'm gonna do 10 here. So this is all the answers. Do they have an answer here? No, you need to. So one way to do this is, I do not suggest you. So you type this out. So you put, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because you got 10 p's. So this is 0 to 10. And then you do each and every single one of this. When you do 0, this is 0.00000095. It's a lot of work. When you put x is 1, exactly 1, this is 0.123452861. I'm not calling you to do this. I'm just doing this for you guys so you guys can see why it's a lot of work. Then for 2, you get 0.0003864. So you're gonna do this for all of this. You're gonna cry if you do this way. And then you go 0.0030899. So if I can I over here? Nope. For 0. Oops, sorry. Don't do this in your test. You can. I didn't say it's wrong, but it's a lot of work. Okay. 0.0583992. And I show it to you a shortcut to do this. 6 is 0.145998. Oh yeah, 7. 0.250282229. 8. 0.28156757. Class, don't do this in your tests. Okay. If you forget the formula, then yes. That's why I call you. If you forget your formula, then the last one is 0.05631351. So so you enter all this, and then what you do, like in 5.1, you go for your stat, calculator, and custom. Remember, in 5.1 you find the mean and standard deviation. You go to stat, calculator, custom, and then the values in var1 is your x, and weight in var2 is the probability, and you compute. And you get yourself your mean, which is this one essentially. So in this case, this is the long way to do this. So your mean in this case, your population mean is 7.5, and your population standard deviation is 1.369. Okay, so this is a very long way to do it, right? You have to type in every single one of this in there using this, changing the binomial calculator from 0 to 10, a lot of work. And then after that, you go to the custom one and do your x and px, but you learn 5.1, and then you do this. It's correct, it's not wrong, but there is a shortcut to do this. And the shortcut to do this is using the formula. So this is a formula I told you, the NP and the square root of NPQ. Okay, so what you need to do here is, you can do this, it's not wrong, or you use the formula. So the formula to find the population mean is n times p. So what you do is n is 10 times with p, 0.75. Can someone tell me what is 10 times 0.75? Is 7.5.
Yeah.
You get the same thing as here. But do you need to do all this crazy work? No. Now, to find the population standard deviation is the square root of NPQ. Now, as you know that if your P is 75% or 0.75, can someone tell me what is Q is? So what is 75 says green, so what percent is not green? point. Anyone?
25.
0.25 because it's 1 minus it, right? So 1 minus 0.75, you get 0.25. So in order for you to find this standard deviation, you have to take out your calculator, type in the square root of n, which is 10, times 0.75 times 0.25. So square root of multiply NPQ in this case. So I will take out your calculator, make sure you know how to do this. This is not that difficult compared to the one I showed you. So n is 10, 0.75 is your p, and q is 0.25. And then I need to take the square root of it. Don't forget, you take a square root of this fellow. So this is 1.36. Is that the same as what we just got in here? Yes, it's exactly almost, I mean, it's almost the same, right? Class, up to you how you do this. If you forget the formulas, then you have to do the long way, which is the way I just showed it to you. You have to enter 0, 1, 2, 3, 4, 5 over here, use the exact and put it over here. And then after that, you have to do the custom case, okay? But if you know your formula, this is the formula case here, I will recommend you to use the formula, right? Because that is a bit more easier to do than using the one that I showed to you early on. Okay. B in this case, if you read B, they ask you for the ROROT. So so you guys know what ROROT stands for? Range of rule of thumb, right? What does that use? What formula is that? You take the mean plus minus 2 times the standard deviation, right?
Yeah.
And the mean that you have here is 7.5 plus minus 2 times, and your standard deviation is 1.369, right? So take out your calculator and figure out what is your lower and what is your upper. Okay. So once you get this, you can figure out your range of rule of thumb. So 7.5 minus 2 times 1.369. The low one in this case is 4 point something, 4.762. And upper one, you just change the plus, so 7.5. Oops. Calculator here. So 2 times 1.369. So this is 10.2 something, 10.23. Oops, sorry. My God, what do I have? 10 point something, right? I missed that one. 10.238. And the units for this is, what's a unit? Anyone remember what's a unit here? This is a question. What's a unit? Numbers of what?
Peas.
Peas with what
Green
color? So this is
Green
green peas. Yep. So this is the number of green peas. So that is your unit. This is your unit here. Yep. This is your unit. Okay. So that's your unit in this case. So so that means that if you have 4 or below, it's considered significantly low. If you have 11 and above, it's considered significantly high. Okay, so this is how you figure out significantly low and significantly high using range of rule of thumb. So now my question is a result of 9 peas with the green pods are significantly high? So my question is, you look at range of rule of thumb, is 9 in or outside this range?
It's in.
It's in. So is that significantly high? Yes or no?
No.
So this is 9 is not significantly high because 9 is inside ROROT. Okay, inside the range of rule of thumb. And if it's 11, then 11 is significantly high. Okay, but 9 is not. So so this is how we do this. So you do not need to use the probability that you did on number E, part E here. Remember, we use the probability to do this. The reason why we use we use probability to do here is because it doesn't know the range of rule of thumb. You can find the range of rule of thumb. You have to find the mean, like here, and the standard deviation, and then use that. You can do that on part E. It's a lot of work. Okay, so in my test, you can do that too, or you can find the probability here. So for me, I'm pretty open with it, so I don't really care which one you're gonna use. Yes, I'm gonna take attendance here, so please type in present here, and we'll do the last question. Okay. All right. So let's read the last question here. The MedAssist Pharmaceutical Company received a large shipment of aspirin and used this sampling pad, randomly selected and test 40 tablets. Accept the batch if there is one or none that meet the requirement. Out of the shipments of 5,000 aspirin, the rate is 3% rate of deflect. What is the probability that this whole shipment will be accepted? So again, as usual, we need to know your NPX. And yes, this is binomial. Sorry. NPX. Anyone know what's the N here?
40.
40. We don't use that 5,000 here. This is just, don't use that. This is came from a 3% deflect rate. So don't use a 5,000. So in this case, 40 tablets is the one. What is the probability that this is deflected? That means no good.
3%.
3%, 0.03. And what is your X in this case? This is where a lot of students cannot find X. Anyone find X here? I know where the X is. So in order for you to accept this batch, how many out of these 40 tablets is considered that you accept?
3%.
One or none. See this? So in this case, X will be what? What do you mean by one or none? What number is that?
1,
One or
0.
yes. Okay. So in this case, you have to figure out what is the probability of getting one and what is the probability of you getting 0. So let's find what is the probability of you getting 0 first. Exactly. So this is exact. So you're going to find 2. Exactly 0. So how do we find exactly 0 in your binomial calculator here? Is you have to type in this. So n in this case will be 40. So n will be 40. Probability of deflect is 0.03. 0.03. Exactly 0. Exactly 0 is this one. So that probability is 0.2957. This is for exactly 0. And now you need to find exactly 1. So which is the same thing we did here, but you just need to change that 0 to become 1. So for that case, probability of X equals to 1 is 0.365 with all these numbers, right? So what are you gonna do with these two probability now once you find the 0 and 1?
You add them together.
You add them together. So in this case, in order for you to figure out the accept rate, you add these two together. P0 plus P1. So take out your calculator, add 0.2957 and 0.3625. Not 25, 0.3658. 58. Not 25. This is 58. Right? 3658.
0.6615,
0.6615,
0.6615.
something like that, right? So the question, so this is how you find the probability of accept. Now, if you do not want to do this, you can also use in here, less than or equals to 1. See that? Or you can do px less than or equals to 1, which is the same thing as 0 and 1 when you add together, and you still get the same answer, 0.06615. See that? So last time I used exactly, you can use less than or equal to. This is the same thing, okay? So my question to you is still one more left. This is the probability. So is this shipment be accepted or will many be rejected? So the only accepting rate is only 66%. You think 66% is a good acceptance rate or this is 66%, right? Is 66% a good acceptance rate? The answer is many will be rejected in this case, because probability of accept in this case is only 0.6615, which is very low, which is less than 95%. Okay, don't forget we use a 5%, right? Anything that is below 5% is considered significantly low or high. So if you want to be mostly be accepted, your accepted region will be more than 95%. So opposite of 5% is 95. So in order for you to answer that mostly of a shipment is being accepted, this probability has to be more than 95%. But unfortunately, this is only 66%, which is really low acceptance rate. So in this case, your answer will be many will be rejected here because your probability is too small. Okay, 66% is not high enough. 95% and above is considered good. That means you'll be accepting the shipment in this case.
Wait, where did you get the 95% from?
It's the 5%. Remember the 5%, less than 5%? Now we do the opposite of 5%, which is 95%.
Oh, okay.
Yep. So we do that. So because we want accept, we don't want reject. You guys with me here? So we want to accept. So in order for us to have accept, we want a big percent, and that percent is 95%. Where we get the 95% from is from the 5% that we use too, which is the opposite of it. So we always use the 95% for the good part, for the accept part.
So when you're accepting, you use 0.95. When you're rejecting, you use 0.95.
When you do reject, we don't do okay, here you go. When you go accept for just this question, okay, just this question, it has to be more than 95%. When you reject, it has to be less than 95. So that's why this will be reject, because this number is less than 95%. Okay. Just for this question, not for the, don't get this question mixed up with significantly high, significantly low, because this question did not ask for significantly high, significantly low. This question is asking for acceptance rate. So for this case, the acceptance rate has to be, the probability has to be more than 95%. And for the rejection rate, the probability is the accept is less than 95. Because of this case, it's only 66%, so it's less than that. So we will reject. Just for this question. And don't get this mixed up with the significantly and low and significantly high. They are two different things. Tough, right? Things are getting tougher here. I do suggest you guys to I think I sent up an email like 2 weeks ago regarding with the getting help from the Math Resource Center, getting help from me. So please, things are getting difficult here. It's not easy. So make sure you guys get help either from me or from the Math Resource Center, because you can tell the material that we're covering here is no longer as easy as finding mean median. is going to be, doing all this probability work here. Okay. So I'm going to stop the Zoom meeting here. And yes, I will post this in D2L. So you guys, the one that I've written down here on blue. So please go to D2L and check it. I will post all this in there together with the video for today. Okay. So you can refer to it. Anyone have any questions for me? Make sure you put your attendance down.